Here we have a question which requires us to translate one kind of graph to another graph. So in the question, we have a velocity time graph of an object which is given, and we have to draw the variation of position time graph. Okay. So first we are going to draw our axes, right? The y-axis could be of any size. This is our t. Mark the key timelines 0.5, 1, 1.5, and now let's see what this velocity time graph tells us. The velocity time graph is a flat line, right? Which means my velocity is constant. Okay, it's not changing. So that's the one thing we know. And when your velocity constant, basically in the position time graph, you are going to get a graph which has a constant slope. Okay, so roughly we are going to look at something like that. Let's see what extra information we have. Says the initial position of the object is 0. So at t equal to 0, we get our first point. We are over here, right? Another aspect of the velocity time graph is that the area under this curve, right? Area under the curve is going to give us the displacement. So with that, basically we can get a very accurate graph. So let's say this is 1, right? 2. So in the first 0.5 second, we are going to travel a distance of 1 into half. So we are going to mark it over here. Let's say 0.5, right? So the first, and we are going to be here. Then between 0 and 1, we are going to travel a distance of 1 into 1, right? So we will be roughly around here. Then 1.5 into 1. So we are going to mark further. So 1.5, and we are going to get 1.5 and 2, this whole area, right? So this is 2 into 1, which is 2 units. So roughly around here. So we'll just make our axis bigger, right? So this is 2. So this is 3 here. And as expected, we have a graph with a constant slope. Now we can simply connect them, and we are going to get a graph, the distance time graph, which is a upward sloping line, which means we have a positive velocity, right? And because it has a constant slope, which means have a constant velocity as well. And this is how our graph will look like in the final answer.